Okay, welcome again to SolarGain's latest podcast. This time we're going to talk about system design. So, system design is something that on our initial visit we will put into practice, and that's what we'll send you a written proposal all about. So all of the factors that go into the quote we send you are incorporated within system design, really. And so I think it's important to say why we do design things the way that we do, and what the different parts of a system are. So that's kind of what I was going to do. In the first conversation, I normally ask, what do you already know about solar? Because I don't think there's anything worse than going into somebody's home and they've already done loads of research and they're all geared up and they know everything that they just got a couple of really deep technical questions, and you start sort of pointing out, this is a panel, this goes on the roof.
Well, I'm guessing you get two different types of customer.
Well, there's lots of different
different types. But as in, there's those that are researched and those that are claimed to say, I know nothing. Yeah. Tell me everything.
Yeah. Maybe. And there could be somewhere in between.
Somewhere in between.
And some people have lived with solar, but that was years ago that it was installed, old technology, and they've not kept up, so things change. Yeah. So when I think about system design, I think about component parts. Generally, that's solar panels on the roof. Doesn't have to be on the roof. Obviously, they can be ground mounts, they can be wall mounted, they can be mounted on fences, they can go on the roof. Most of the installations we do, though, are on the roof. So I always think panels on the roof, because it's already a pitched oriented structure. It's there. It's ready to take them. And it's usually the most cost effective way of installing. So solar panels go on the roof. Then we've got a cable somehow down towards where the inverter's going to go. Then we've got an inverter. We'll talk about what that is. Then we've got usually a battery system, but not always. And then we've got things like isolators and meters and stuff like that. Yep. Collins stuff.
Electrical bits.
Electrical stuff.
Yep.
Yeah. So, I suppose when you get a little bit further along the road, then you think about, well, is there a difference in panel types? So, I've done all sorts of research into panels, and we see what comes through to the market. There was a panel that claimed to be the world's first AC solar panel. And I thought, this is amazing. All panels are DC. We know this. So how is this market changing? So I looked at it, and it turned out to be a normal DC solar panel with a T-Go strapped to the back. Right. At the point of leaving the warehouse. So you've taken two different products, put them together, and done what we all do every day on the roof.
Nothing new.
Nothing new. But it also came with an amazing, I think it was like a 40-year warranty, something like that. But given the rest of the marketing spiel, I kind of moved away from it and went, I don't think you're going to be there in 40 years. So that's relevant, isn't it? Yeah. Warranties and things. But let's go back to design. They bring out things like mono, perk, half cell, optimized. What we had shingled. Do you remember shingled panels? No. Okay. So in the old days, you would have a silicon wafer with a crystal structure in it. There's no moving parts. It's got glass over the top. So the light goes onto the glass. It creates almost like piezoelectric. It creates a chemical reaction in the crystal, and that creates current voltage. Yeah. So that's how your power is created. And then what they started doing was go, well, that gets really hot. So in order to make it more effective, we'll cut it into little squares, and we'll start putting little squares in with spaces in between. So they started doing that. And then they cut them into little strands and strips. And then they started layering them one over the other to give you like a little, almost like a fence panel is layered like that. They started doing that. So you've got this coolness because you've got an air layer, and then you've also got it slightly more tilted towards the sun. And what happens if you put it up the wrong way? Anyway, it's all gimmicks. I think a lot of it's gimmicks. You've got bifacials now, and there's the idea that light comes back from the roof structure. What if you put it in a GSE tray? It doesn't have to be GSE. Other trays are available. Are you going to get any reflected light? Will the light go through and come back off a black surface? I don't know.
I'm still not convinced about it.
When I look at the data sheet, what I want to know is, what is the physical size of that panel? What is the wattage that panel is going to give me? And what's its efficiency to some degree? But the efficiencies tend to be, what's the efficiency of a panel?
20%.
It's about that, isn't it? It's like 21 to 23%. And there's some tiny margins between them. But generally, most of the big panel manufacturers will tell you what their wattage is. They'll give you a really good warranty. They're probably likely to be here to support. It's on the MCS register, and it's a panel. And they're the cheapest part of the system relatively in terms of overall cost to install, and the only things that generate. So having panels that fill your roof space where possible is useful.
As I say, the roof space is probably quite an important one. You've got a set area. You've got to try and fit in what you can in that area.
Yep.
Based on the area and also other things like house, what the electricity they're using, that kind of thing.
Yes, they're the two defining factors, which I haven't got onto yet.
Okay.
That's okay.
I'm just fast forwarding you.
Yeah, brilliant. It needs to be done. So yeah, you're right. I mean, the two limiting factors or the defining factors for the system are how much can we actually create in terms of generation and how much of that are you going to use? Because if we had an infinite rooftop where we could put an infinite number of panels, you'd very soon get to a point where you're getting no more benefit and you're just powering the grid. And that's not useful. So, I mean, it can be useful. You can make money out of it to a small degree.
Yeah.
But if we think in simple terms of income and outgoing, every kilowatt hour that comes off the roof, so every unit of energy that you use in your home is worth twice as much as every one that you might sell in the current market. Obviously that could change.
Yeah.
And it has gone up quite a lot recently. It used to be poles apart, didn't it?
Oh, long way apart. Long way apart. It's now actually worth doing.
Yes. So if we rewind a little bit, the industry had feed-in tariffs and things like that. They were government incentives to get people to fit the product onto the roof so that people would see it working in houses and everyone would talk about it, and you'd have a reference you could go to and say, well, does it actually work? So it was about putting it out there in the mainstream. And once it became mainstream, they took the subsidies away, tapered them off because they weren't needed anymore. And the product has proven itself, hasn't it, effectively?
Yeah.
Some people say, oh, well, they got great payouts and they're still getting paid well for it. And they are good systems, and you do need to keep the integrity of those systems if you've got one. But it was a gamble back then. You paid a lot for a system like that with no battery.
Yeah.
The average was about £15,000 to £20,000 installation.
Yeah, I would say 12 to 15 maybe ish, and that's with no battery.
Yeah.
That's a lot more panels as well because they were smaller in terms of wattage.
Yeah.
And yeah, you'd get money for just generating it. But you wouldn't get much money for exporting it.
No. Well, I don't think there were export tariffs, were there?
They were, well, it was deemed.
Well, they moved. You had a 50% potential that you would have. You would use that power, and the rest would go to export.
That's what they used to call the export tariff. Was
right.
They calculated that you would export half of what you generated.
Yep.
No. There was no measure of it. There was nothing logging that. So, whatever you generated, you got half back, and it was like a few pence.
Yep. And then they moved to SEG, didn't they? So SEG was like the Smart Export Guarantee. That was designed then to give you a route to market for any power that you had. But most of the electric companies, or the utility companies, I should say, didn't really want to buy your power. And it was 2, 3, 4 pence a kilowatt hour, whereas you were paying 20 something. But I think in broad terms at the moment of about 30p to buy a kilowatt hour and 15p to sell it, something like that. That's kind of where the market sits.
That's pretty average, isn't it?
Yeah. So each one that you use yourself, designing power that you use yourself is more beneficial than designing extra power that goes to the grid. But there is a value to it still. That's all I was trying to say. Okay. So rooftop stuff, warranties generally sit around 25 to 30 years. Physical warranties about 25 years mostly. The power warranty, linear power output is going to be 90%, 87.4% if it's a 30-year projection. It's the same curve effectively, but the product after 30 years on the roof is still going to give you 90% of what it did when you first fitted it. So the longevity on panels now is incredible. And most of the companies that are selling en masse, they're rolling out of static sensitive factories. The fault tolerance is incredibly high. There's very few faulty panels. I can't think of any we've fitted in the last couple of years that have been faulty other than the ones we've dropped.
No, I don't think they have. It's a very unusual thing. Very unusual thing for them to go wrong. There are still a lot of systems out there that were fitted in the old feed-in tariff days from 2010, 11-ish. Still going, still happening, still working, still generating.
Yeah. And a fairly low-cost modular item, so if they do develop a fault, they can be changed, but there are some practical difficulties to that. So we probably ought to move on and talk about the rest of the other parts. We've got an inverter and a battery. So inverters, in my mind, come in 3 types. You've got a hybrid inverter, which is what most modern fits will be. That just means it's an amalgamation of 2 different things. Its first job is to change the DC power that comes off the solar panel on the roof into AC power so you can use it in the home. The other job it has is battery management. So you will attach a battery to a hybrid inverter and it will manage the battery for you. So 2 jobs married together, hybrid. The older design was a string inverter or a grid tied or a PV inverter. PV just stands for photovoltaic, by the way. And they don't have batteries attached. So that's a very simple, when the sun comes out, you create power, the power goes onto your home electrics, and either you use it at that point or it flows away to the grid and just adds to the voltage there. The other type is microinverters, and this comes up relatively regularly. I think microinverters have a place. A microinverter is a small inverter box that is effectively connected to the back of each individual panel when you do the fit. And they are very simple pieces of equipment. They have really long warranties, like 25 years, whereas most inverters sit at around 10 years. Give Energy's got a 12-year warranty. Depends on the manufacturer.
It does depend on manufacturer, yeah.
But 25 years for a microinverter, I think that's the end phase that I'm thinking of specifically. Very simple, very little to go wrong. The only problem I see with that is that if you do have to investigate a problem, you're going to be working on the roof, which means scaffolding and taking panels off and all of that. Whereas if you've got a central box, then you can just look at that central box and it's usually accessible.
Yeah.
So I think in terms of fault tolerance, but again, this comes back to system design. What you really want to do is design a system that works for the needs of that customer.
Yeah.
So if you've got a roof that's really multifaceted, think of something that's like octagonal, loads of different faces around a turret. I don't know who lives in castles and buys solar. I'm sure people do. But that would possibly work really well with microinverters, because most domestic inverters only have two inputs. So if you had an east and west roof, you might put the east onto one input and the west onto another, and that works really well. If you have to kind of blur that or mix orientations together, you end up creating a natural shading problem. And so, and by that I mean when we haven't talked about strings, have we?
If you shade part of one panel that is connected to several other panels, that will bring down the power output of all of them.
Yes.
Not just the one, all of them.
So almost like water finds a lower level.
Yeah, kind of. So in those terms, if you've got, as you were saying, things that are angles in different directions, you're going to get different light off of them. And if they're connected to these, shall we say, I'm going to get these out there. So if these are connected to these on either side,
yep,
one side's going to be a lot darker than the other. That's going to drag down every single panel to be at the lowest point, lowest level of output.
Okay.
And therefore, as you say, microinverters work in that instance. They are good for that.
Well, you can also use optimizers, can't you?
Optimizers.
So optimizers are a slightly, I would say, more cost-effective way of achieving the same outcome of balancing shade. So again, that's part of a system design. But it just depends on the inputs to your inverter. So that's something we take into account when we come out and we look at your building and we look at what's needed. Generally, I would say we try to remove complexity. So if you don't have a multifaceted roof, why do you need microinverters? If you don't have a need for generators and wind turbines and other things, and you're not in a rural property, if you're in suburbia, then we would design a simple system that would work with that and doesn't need those inputs. Because the more complicated the equipment we fit, the more chance of a fault further down the road. So simplicity is kind of key.
Yeah.
Most systems will be hybrid. Some systems will be a string inverter, and occasionally we will fit microinverters, but not very often. Battery systems is the next part. If it's a hybrid inverter, the battery goes with it. They're fitted together because the leads are only about that long, aren't they? A couple of meters.
Yeah.
So they tend to be fitted in the same space, or they have to be fitted in the same space. If you need to do something different, or if you've got an existing feed-in tariff, so you don't want to disrupt that system, there's things we can talk about there, but you would add what's called an AC coupled battery, of which there are a couple of types.
Yeah.
I'm thinking all-in-ones.
Yeah, they're all pretty similar. They're just, it's an inverter with a battery.
Yes.
It's another inverter with a battery, some built in, some built together, some separate. They will sit and monitor what's coming in and out of the building, and if there's excess, it will send it to the battery and charge the battery. It's simple as that, really.
But if you've got a grid tied or a string inverter, like an old feed-in tariff system, and you want to leave that alone, then we would come and add an AC coupled battery. And if we did that, then that kind of doesn't take the feed from the solar panels. The string inverter puts the voltage straight onto the home electric, so the voltage in the house begins to rise. And then as that pours out to the grid, I always think in terms of water, because it's just naturally it makes more sense. If you think you have like a voltage level in the house and a voltage level on the grid, if the house voltage rises, almost like water, it will pour out over a wall or, through the meter. And in the old ways, the analog, the meter would spin, wouldn't it, as like a water wheel.
Yeah.
And if it were coming in the other way, it would spin the other way. Well, that's almost how an import and export meter works, really, in layman's terms.
Yeah.
So when that voltage starts to go out to the grid, you've got a thing called a CT clamp, haven't you? It's a current transformer. Is that what it stands for?
Yes.
Okay, so that monitors direction of current and the amplitude, so the size of the current, the amount of current that's going in or out.
Yeah.
So in my simple brain, what happens when you have an AC coupled battery is that as the the current starts to pour out to the grid, the CT clamp sees that and tells the thing to switch on and start power matching however much is going out.
Yeah.
So you're almost kind of manually adjusting, albeit with a slight delay.
Yeah, there is. It is just sitting there monitoring and saying, oh, look, I can see there's wasted energy there, electricity leaving the building. Right, I want to do something with that. And it grabs hold of it, puts it in the battery at whatever rate it's leaving the building. So it's not like it's a kilowatt leaving the building and it's going, right, I'll charge it 2 kilowatts. And it's going, right, there's a kilowatt leaving the building, I'll charge it a kilowatt. Yeah. So that it's just making use of excess that you're not using in the property. So as a cloud comes over and your voltage or your production dips, instead of pulling in power from the grid, it just lowers its own rate based on what's going out. So the only other thing I would talk about in system design, probably simple things like EV chargers. A lot of people ask about EV chargers. If I want to future-proof my home, do I need to have a battery? Because I might want an electric car later. Well, an electric car is a battery. In fact, it's a monster of a battery. It's huge compared to most batteries. And when you plug them in, you normally have to protect your home battery, which we can show you how to do. Not physically with a shield and sword, that kind of thing. All through the settings on the inverter, we can protect that battery to make sure that the car doesn't absorb all the power out of it, because it will just draw everything. It will soak it up in the first 45 minutes or so. Yeah. And then you're cycling that battery unnecessarily, which shortens the life of it, and we don't want to do that. So if you're going to think about having an electric vehicle, in most circumstances, I would say most people will choose to charge at night, or something like, from a low-cost tariff, which is set by your utility company. You can also generally charge your solar system batteries at that time too, so you get offsetting of your usage, which can be really useful. We can help you to understand how to calculate the benefits of that. But generally, I would say you don't need to do anything to protect your home in terms of future-proofing to add an EV charger. No. Just install the system you're going to install that's right for you. And when the EV charger comes, it's a bolt-on, it's an add-on product. And we just tailor the system really to work with that. Yeah, with hybrid systems, you can add batteries as well. So it's very easy to add to the system, make it bigger. Yep. Make it more usable. The first benefit of battery comes from that smallest bit that you add, the initial bit of battery. It's almost like a law of diminishing returns. So if you add a battery, it's really small, that will give you the best bang for your buck, if you like. And as you add go larger and larger and add more and more batteries, eventually they will add no benefit whatsoever, because your solar can't drive enough power to fill them. That's what's going to happen, particularly in the winter. They will just sit there empty. And batteries are a really expensive part of the system, unlike solar panels. So you're going to pay a lot of money for a product that just doesn't give you a return. Unless you're charging overnight and able to charge it overnight and charge enough of it overnight. Yes. At a cheap rate and then sell it back. Exactly that. But that's tariff dependent. Yeah. And you also have to be using that much power to make it worthwhile. Yeah. And that's why, again, we come back to how much power do you consume. Yeah. So in terms of system design, there's all sorts of things. We look at all of that and put that together in your proposal. But there are also some bolt-on products, things like hot water diverters and other things that were created for a market where your excess electricity was worth very little, and it was being wasted, really. Yeah, and better to harvest it and use it. And they're really intelligent products. But I think further down the road, we're going to do some investigation into whether they're still relevant today. And my simple approach to it is it depends very much on your circumstance. Yeah. But we'll look at all that later on. Is there anything else we ought to talk about for system design? Don't think so. We've talked about shading. We've talked about panels, different types of systems. Yeah, batteries, inverters, string inverters, hybrid inverters, microinverters, optimizers, planning on roofs, feed-in tariff, a bit. I think that's pretty much all of it. But, I think so. For a whistle stop. Yeah. Again, I'd like to come back and really dig into some of this stuff and start pulling it apart, opening the box and seeing what goes on inside. And we'll do that, I think, for each of the component parts, but can't do all that at once. So in summary, then, when we think about designing a system, we really want to be looking at the constraints presented by the roof, its pitch, orientation and size, what size of inverter we need to connect to that, and what size might be accepted by National Grid, which we didn't talk about.
and what size might be accepted by National Grid. The batteries, the battery size, and again, that's going to be dependent on how much power you can generate and how much power you use. And then any sundry or add-on products that need to be thought about. And again, that will depend on your circumstance, home domestic heating, all those sorts of things. I think for now that will do, and we will come back in the next episode and have a look and talk about what we're going to talk about next.
Installation.
Installations. Let's do that.
Installation.